Hi student, welcome back to my channel. In today's episode, we'll explore the concept of complex number and their operations. On the screen, we'll see a diagram illustrating the relationship between real numbers and complex number. In previous episodes, we discussed the real number systems, which consists of the numbers we encounter in our daily life. However, there are also imaginary numbers, which are not typically part of our daily experience. These imaginary numbers were introduced by mathematicians in around 16th century, but are formed by combining real numbers and imaginary numbers. We will define complex numbers shortly. But it is important to clarify that the term imaginary suggests that these numbers are not real in the conventional sense. Use them as a mathematical tool to help solve problems, especially in cases where real solutions do not exist. The foundation of imaginary numbers is the introduction of I, defined as the square root of negative 1. Prior to this, it was commonly stated that the square root of a negative number does not exist. However, mathematicians in the 16th century defined this impossible square root as I. Once we accept I as the square root of negative 1, we can express various square roots of negative numbers in terms of I. For example, the square root of negative 25 can be expressed as the product of negative 1 times 25. The first term, the square root of negative 1 become I, so it will become 5i. Okay, we can do the same thing on square root negative 16. We obtain 4i. In manner, the square root of negative 10 is equal to I times square root of 10. We know that 10 is not a square number, so we can say that it is equal to I times root 10. But usually, we put I at the back of the number. So usually we write root 10 I. The square root of negative 32. We need to simplify the root 32, although it is not a square number, but we can simplify as the square root of 16 and times 2. So the first one become take the square root, it will become 4. So 4 root 2. Usually we will say that 4 root 2i. Complex numbers consist of a real part and an imaginary part. For example, in 3 plus 5i, 3 is the real part and 5 is the imaginary part. In negative 2 plus 3 over 4i, negative 2 is the real part and 3 over 4 is the imaginary part. As illustrated in the diagram, real number can be viewed as a special case of complex numbers, where the imaginary part is 0. Similarly, imaginary numbers are a special case of complex number with the real part of 0. Somebody call imaginary numbers pure imaginary numbers. Therefore, the most comprehensive number system is that complex numbers, which include both real numbers and imaginary numbers. The addition and subtraction of complex numbers are performed by separately operating on the real part and the imaginary part. Okay, let's see some examples. These two examples, the numbers in blue are separately add or subtract. In the same manner, all the imaginary parts are written in green, so they are calculated together. Let's do some examples. Question 2 is an addition. We need to separate the real part and emerging products. Okay, so that's negative 4 plus negative 2. Okay, they are real products, and 7i plus negative 5i. Okay, so negative 4 minus 2, negative 6, and 7 minus 5 is 2, so plus 2i. Okay, next one is subtractions. Once again, we need to put the real product together. So that's 6 minus 7 and plus 9i. Okay, bear in mind that minus negative 2i, so it will become plus 2i. So negative 1 plus 11i. Okay, last one, there are 3 complex numbers. We can apply the same principle. We put all the real product together, h minus 3 and minus 1. Okay, the first bracket is the real product, and plus 5i minus log minus plus 2i, and then minus 6i. Okay, so it will become 4 plus 1i. 1i is actually I. Okay, on this page, we learn how to multiply complex numbers. We can explain 2 brackets as usual, but only one thing difference. I square is negative 1. So when we multiply 2 brackets, when we see I square, that is equal to negative 1. So you see that the negative 20 and negative 3i squared become positive 3, and we simplify and get the final answer. We explain these 2 brackets. Okay, hi times the 2 numbers 40hi minus hi squared, and then minus 6 plus I. Minus I squared is negative 1. So these 2 numbers are the real product. So h minus 6 plus 40hi plus I. So the final answer is 2 plus 49i. Okay, question says 1 plus 5i times 1 minus 5i. It is in the form of a plus b times a minus b. So we can use the formula. It is equal to a squared minus b squared. So in this case, you can say I squared minus 5i squared. Okay, remember to put a brackets. So it is equal to 1 minus 25i squared. Okay, I squared is negative 1, so the final answer is 26. Okay, 7 plus 2i whole square. We can use the formula a squared plus 2ab plus b squared. So 7 squared plus 2 times 7 times 2i plus 2i whole square. 49 plus 28i. The last one will become 4i squared. Okay, 4i squared is negative 4. So 49 minus 4 is 45 plus 28i. The powers of I has a circulating properties. Okay, let's see what I mean. I to the power 1 is I itself, of course. I squared is negative 1. Okay, when we time I to the both sides, we have I to the power 3 is negative I. Time I to the both sides, we have I to the power 4 is 1. Okay, if we multiply I to both sides, we see that I to the power 5 will go back to I. Okay, and then the next one will be equal to negative 1, negative I, and 1. Okay, so you see that I to the power 4 or the multiple of 4 will be equal to 1. By using this property, we can solve question 8 and 9 easily. Okay, let's see what I mean. I to the power 2020 times I to the power 3. Please look that 2020 is a multiple of 4. Okay, so the first term is equal to 1 times I to the power 3. So the result is I to the power 3. 3I to the power 23 times 4I to the power 19. Okay, is equal to 12I to the power 42. Okay, so I to the power 20 times I square. I to the power 40 become 1. I square become negative 1. So the answer is negative 12. In today's episode, we have learned the addition, subtraction, and multiplication of complex numbers. In the next episode, we will learn the division and some applications. Okay, see you next time. Bye bye.